அது முடிச்ச உடனே நீங்க ஆரம்பிச்சிடலாம்.
ஓகே
ஓகே சார், லைவ் ஆரம்பிச்சிருச்சு. முதல் சார்.
ஓகே சார். HOD சார்.
we are on live sir. Okay sir.
HOD சார்.
ஸ்டார்ட் பண்ணலாமா?
ஸ்டார்ட் பண்ணலாங்க சார். லைவ் ஆரம்பிச்சிருச்சு சார்.
ஓகே ஓகே ஓகே.
பார்ட்டிசிபென்ட்ஸ் ஆர் ஆன் தி வே.
39 கிராஸ்ல.
ஆமா சார்.
சார் நீங்க ஸ்டார்ட் பண்ணுங்க சார், அப்படியே மத்தவங்க ஜாயின் பண்ண ஆரம்பிச்சுவாங்க சார்.
நம்ம ஸ்டார்ட் பண்ணிடுவோம் சார் அப்படியே.
Good morning, one and all. I am very happy to welcome you all for the second day of the workshop on artificial intelligence and image processing using MATLAB. I hope you had a great and useful time yesterday. I welcome the resource person, Mr. D. Rajkumar, application engineer, for today's session. We had a useful time yesterday. Thank you, Mr. Rajkumar. Once again, I welcome all on behalf of EC department. Mr. Rajkumar, you can start your session, sir.
Thank you, sir. Good morning to everyone. I hope my audio is fine. Everyone able to see my presentation slides? Vidal sir, you able to see my screen?
Yes sir, yes sir. It is visible.
Okay. If everything is okay, we shall start the session. Today I'm going to present on artificial intelligence with MATLAB. Today mainly we are going to see about what is machine learning, what is deep learning, how you can develop algorithm, develop application and data analysis in the MATLAB environment based on the machine learning and deep learning MATLAB products. Going for the today agenda. Today, mainly we are going to see about the machine learning concept. What are the machine learning concept is the algorithm is how to easily develop the application, and then deep learning. What are the deep learning? How to you can design the deep learning architecture, how to make into the layer sets. There are different kind of types in the deep learning. We are going to see. After that, we will move on to the MATLAB user story on artificial intelligence. One user story on artificial intelligence. Before going to know about the artificial intelligence concept, we will know some history about the artificial intelligence. I will share some history about the artificial intelligence. The artificial intelligence, the first concept is developing machine learning. Machine learning is a subset of artificial intelligence. Going for the artificial intelligence concept, machine learning is a subset of artificial intelligence. Then overcome the limitation. After the some overcome of the limitation, developing the deep learning. Deep learning is a subset of machine learning concept. First in 1956, the first concept of the artificial intelligence coming 1956, but just a theoretical concept. The 1950s only developed in the theoretical concept. After then 80s and 90s. 80s and 90s we are taking about the neural networks. That time also we not enough that much computer power, so that we are not able to utilize properly in the artificial intelligence concept. Then finally 90s and 20s only we are starting using the neural network working for machine learning concept. 1920s also not we are directly moving on to the deep learning. That time also we are working for the machine learning concept. Then 2006 only the first term of the deep learning was coming first time. Then overcome of the limitation of machine learning. After that the is subset of the concept of the machine learning. Then finally 2010 we are using deep learning was a commercial products also we are using the deep learning concept. This was just a small history about the artificial intelligence. We are going for the artificial intelligence. Artificial intelligence is a power of machine to copy a intelligence of human behavior. Just a one line definition about the artificial intelligence means the power of machine to copy a intelligence human behavior. That's why I am mentioning in the brief description about artificial intelligence. Simply I say mean where we are using the artificial intelligence. Give the example for we are using the daily life. We are monitoring some say example we want to monitoring the road vehicles in the road. We want to monitoring the road vehicles numbers, how many vehicles is running in the road, and what kind of vehicles is running the road. Human is not possible to count all the how many vehicles is there based on the speed limit. We not able to count the list, but the artificial intelligence easily capture the vehicle images, vehicle number plates, easily monitor and take the solve it results. That's a one small example about the artificial intelligence. Most of in the artificial intelligence, lot of nowadays lot of concept was developing. All the divisions, all the innovations added the artificial intelligence concept. Some relevant example in the artificial intelligence: Google Waymo self-driving car, and then Honda Simo humanoid robot, Amazon delivery drone. Amazon also planning to developing the delivery drones in India also, and going for the artificial intelligence in MATLAB. In the MATLAB, in the artificial intelligence concept, development of computer system to perform a task that normally require human intelligence. The same thing of the single line definition: power of machine to copy a intelligence human behavior. The first picture is saying to the semantic segmentation. The first picture is saying to image segmentation, and second one is the reinforcement learning method, artificial intelligence reinforcement learning method. Going for the artificial intelligence application, lot of applications nowadays using the artificial intelligence concept. Object classification, going for the object classification side, we are using the artificial intelligence. Speech recognition like Alexa, Siri, Google Assistant, we are using the artificial intelligence concept. Predictive maintenance, monitoring the machinery system, signal classification, automated driving system. Most of in the automated driving system, stock market prediction. Not only for this application, lot of application using the concept of artificial intelligence. And then going for the next slide, the data types. Most of the research scholars, most of the project people, most of the artificial intelligence working people have the major question is what kind of data sets is suitable for the MATLAB software. MATLAB software totally in the AI types, almost image, text, numeric signals, all kind of data set you can directly apply into the MATLAB software and using the machine learning concept. Going for the machine learning, artificial intelligence modeling with the MATLAB. Taking for the artificial intelligence with MATLAB. Totally in the artificial modeling technique, we are using the 5 major toolboxes in the 5 major MATLAB products. One is a machine learning toolbox. Machine learning toolbox is used to solve all kind of machine learning supervised and unsupervised method. And also in the toolbox name is statistics and machine learning toolbox. It's kind of all analyze and model the data using the statistics and machine learning concept. Next, deep learning toolbox. Deep learning toolbox used to create, analyze and train deep learning toolbox. And then reinforcement learning toolbox is used to design and then train the policy of using the reinforcement learning. Natural language processing, where we are using the natural language processing in text analytics. Especially for natural language processing, we have the toolbox name called text analytic toolbox. It's used to analyze and model the text data, or complete analyze and model the text data. System design almost the predictive maintenance or the other toolbox complete sibling product family is used to AI modeling. And then some similar examples on the applications in the right hand side. This one is the classification learner app. Machine learning, most of in the machine learning part, lot of application is there. We upcoming slides we are seeing about the application. This one is the deep network designer. The deep learning toolboxes used to create the neural networks, and then reinforcement learning toolbox. You are trying to the robot to walking steps, and then text analytic toolbox analyzing the text, and land following control application. This is used for automated driving methods. Next, we are going for the computer. What are the how to the computer we are giving the data sets combined with the machine learning and deep learning. Most of time we are using the traditional programming. Traditional programming is nothing but most of the time we are giving the data and then programming, sending to the computer, Finally, we are getting some outputs. Next, we are going for the machine learning. Machine learning, most often the machine learning side, we are applying data and then output. Output based on the data and output, we are getting the programming. Previous that traditional, most of the people are using the traditional programming method only. Traditional programming, we are applying the data sets, we are writing the programming to the computer. Finally, we are getting the output. But machine learning, the data and then output, the output data sets we are giving to the computer is getting the program. And then deep learning. For the deep learning is completely different than the machine learning. You can get directly from the models. The subset of machine learning, you can directly get the model. Next, AI workflow. Going for the AI workflow. These are the basic workflow for the project. The concept of artificial intelligence. First, we need to access data, where we are taking the access data from the sensor or from the files from the database. Next, we are sending to the analyze data. Analyze data is only in the artificial intelligence. We are doing some exploration, pre-processing, domain-specific algorithm. Next, develop stage. Develop stage, we are applying to the model development, algorithm development. We are suppose we want to sending some machine learning or deep learning concept to the simulation, modeling and simulation concept. Finally, deploy. Deploy, we are deploying to some application level, some enterprise system, or some embedded devices. These are the four major categories to working with AI workflow: access data, analyze data, and then develop and deploy. Next, going for the machine learning. Machine learning is completely based on the data analytics technique that teach computer to the bot naturally the human and animal. We are completely based on the learning process. This completely we are using the most common toolbox name called data analytics toolbox modeling. Taking for the machine learning also ability to learn about the data without being the explainability of the program. It's completely solving the complex handwritten rules. No need to write the handwritten rules and equations. We are directly applying the machine learning algorithms to solving the problem, like a speech recognition, object recognition, and engine health monitoring. Then we are changing the data. Suppose you need weather forecasting, or you need to solve some energy forecasting, or you need to solve some stock market prediction. That also is possible. And then the scaling. So solution needed to the scale. We have the IoT analytics, text availabilities, airline flight delays. These are also we are easily solving using the machine learning concept. And also you can apply the large data into the machine learning and deep learning concept. Going for the machine learning, this is a simple example about the machine learning concept. Taking for this machine learning, first we are applying to the traditional method. Most often the traditional method, we are handwritten programming. We are applying the handwritten programming or formula or equations. We are some written the code and the algorithm, or we are giving the formula or equation. But applying the machine learning approach. Machine learning approach is based on the machine learning algorithm. It is completely based on the machine learning algorithm. I think some background noise is coming. Sir? Please, everyone, mute your mic. Suppose you have any queries during my session, kindly write in the chat box. I will answer the during the session or after the session. Nudal sir? Nudal Srinivasan sir?
Yes sir.
I think some background noise is coming, sir. Please mute.
Okay, sir. Let me see. Okay, sir.
Okay. Taking for the human activity detections. We are most of the traditional approaches. We are writing the programming or formula. Most of the traditional, but machine learning, we are directly applying the algorithms. Algorithm means we are applying directly in the machine learning concept. Taking for the challenges, major challenges of the machine learning, lot of data with many variables. The major challenge of machine learning, data sets, it's more high data sets, taking an image or text or anything, it's more data sets. And then complex equation method, technical express method, and then multiple choosing the algorithms, time constraint. These are the major challenges. And then the solution, taking for the solution, most of in the MATLAB software, you're able to get the application. Most of common application is available into the MATLAB software. Taking for the algorithms application, lot of algorithm and applications available. Taking for the clustering, classification, regressions. We have the apps and neural networks apps is there. Curve feeding apps is there. And then taking for the parallel computing. Where the parallel, we have the MATLAB, the toolbox name called parallel computing toolbox. This parallel computing toolbox used to suppose you want to use, you are applying the huge data sets. That huge data set is separate. You are walking into the multiple CPU and then GPU. That we are using the parallel computing toolbox. Parallel computing toolbox is also available in with the MATLAB software. And then integrated with the data deployment, data analytics workflow. Then we are going for the overview about the machine learning.
Participants, kindly mute your mic, please.
Taking for the machine learning. Machine learning is two type of machine learning is there. There are type of artificial intelligence. Two types of machine learning is there. One is the supervised learning, and another one is the unsupervised learning. Supervised learning is nothing but we easily predict the output based on the input. That is the supervised learning. And unsupervised learning, we cannot predict the output. Correctly, we cannot predict the output. The categories of the algorithm. Taking for the machine learning unsupervised, the categories of the algorithm is the clustering. And then machine learning supervised learning. We are taking for the supervised learning. And then regression method. Taking for the supervised learning, there are two kind of categories of the algorithm. There one is the classification, another one is the regression. I will mute that person. Sorry for that. Taking for the types of learning, the two kind of type of learning, machine learning is there. One is the unsupervised learning, another one is the supervised learning. Categories of the algorithm. Taking for the categories of the algorithm, totally three kind of algorithm is there in the machine learning: clustering, classification, and then regression. Classification and regression is completely based on the input and output. We easily simple that the supervised learning, we easily predict the output. But unsupervised learning, we cannot predict the output. Taking for the unsupervised learning example, we are using the mobile phone. We are getting the mobile phone signal from the one tower, but we are using at the same time we are using the 100 or 50 mobile phone. We cannot able to predict the correct person signals and output. That is the type of unsupervised learning. Clustering. The most of choosing the machine learning concept, we need to the algorithm selection. Most of the people having the doubt about the algorithm selection. Algorithm, most of the supervised or unsupervised, you know the supervised and unsupervised, we know that we easily predict the output, then we are going for the supervised. Taking for the classification, the categories of the classification, regression method, and then supervised, unsupervised method, we cannot predict the output. That time we are choosing the clustering types of the algorithm. But algorithms, inside of the algorithm, different kind of algorithm, is depends of the size of the data sets. What data? Suppose you are using some image data sets. You want to classify the color based thing, or you have the data, some data sets, some Excel data sets. You want to classify, or you want to apply or detect some data in the future data sets, or you have some weather data sets. You want to classify some future prediction level. That kind of time is based on the data sets only. We are applying the algorithm. In the advantage of MATLAB software, most of algorithms, taking for the most of algorithm is available into the MATLAB software. Using the application level, you can directly apply into the apps and getting to the results. Unsupervised learning, these are the algorithm. And then choosing the supervised learning, regression is based on the continuous response value, and classification is based on the categorical response value. Classification side, we are based on the algorithm, based on the data sets, we are choosing the algorithm. And regression side, based on the data sets, we are applying the algorithm. Today we are going to see some example related to the machine learning, the human activity recognition Simulink model for the smartphone deployment. We are developing the one application. My application are a real-time app. This real-time app is done by activities. Using the machine learning concept, I am making that as an application and sending to the data set in the Simulink model. Finally, that Simulink model I am deploying to my mobile phone in the .apk file format. In my application, my output is kind of predict my activities. What kind of activities? Say example, I want to predict based on my accelerometer. We know that mobile phone, we have an accelerometer sensor or gyro sensor. This sensor used to predict the axis, X, Y, Z movement. Suppose we are playing some games in the mobile phone, based on the mobile phone position changing, the inside of the vehicles or inside of the player is automatically changing the position. It's nothing but gyrometer sensor. The same concept we are using that concept to deploying the same app to predict the activities. But this example we are not using to predict the values in the coding format. We are directly applying the machine learning concept in the app basis. I'm switching to the MATLAB software. Udal sir, are you able to see my screen, sir? MATLAB screen?
Yes, sir.
Okay, sir, thank you. This example is a human activity recognition Simulink model for smartphone deployment. This example is completely based on the machine learning concept to predict the values, and then this data sets we are sending to the mobile phone.
Yes, sir. We are seeing.
Yes, sir. Thank you, sir. Before we need to the support package, download and install the Simulink support package. Why this support package mean? We are deploying our data, deploying our model into the smartphone, right? In the format of .apk. The first step, we need the prerequisite, download the Simulink support package. Choosing for the Simulink support package, here, home, add-ons, get hardware support package. Choosing for the get hardware support package, you can see, choosing for the get advanced support package, you can get the complete support package, not only for cameras, not only for, you can import the Simulink, Android Simulink Blackset also. The same method I'm doing here. Android phone, I want to the Android support package for the MATLAB software. Android, I'm typing Android. You can see here Simulink support package for Android device. Once you install the support package, you can get the complete black sets in this Android devices, Simulink support package, and also suppose you have the iOS system, that support package also available. Okay, you can see here. Once add the support package using USB connection, you add your complete black set into the MATLAB software, and also some pre-request support package is requested, Android Studio. Then we are going further developing the model. My app is going to predict the activities. What kind of activity? Mean 5 kind of activities: sitting, standing, walking, running, dancing. Totally 5 kind of activities. These activities is prediction based on my accelerometer sensor. Basically, we know that the accelerometer sensor will predict the axis, X, Y, Z axis. Based on that, we are predict the activity. Suppose we are sitting with the phone, means the phone position, the X, Y, Z axis is different. And also we are standing, means the X, Y, Z action is different. Walking means the changing continuously changing the accelerometer sensor position. Running means it also changing. Based on that, we are predicting the activities. We are developing the model. First, we load the activities. This is an inbuilt example. I'm just copy the load human activities and paste it in the command window. You can see here, once I enter the data, the complete data is automatically coming by workspace. You can see the activities, 5 kind of activities here. The 5 kind of activities: sitting, standing, walking, running, dancing, based on the accelerometer sensor. Next, going for the example, here first we need to the prepare data. In the first step, we are load the data sets, prepare data sets, develop and deploy, the 4 major steps for artificial intelligence. Next, we are going to the prepare the data sets. Prepare the data sets. I am using the 90% observation trained model. Here 90% observation of trained model and 10% observation of valid trained model. I'm using the 2 set of data sets, X-train and then Y-train. You can see here, X-train and then Y-train. X-train data set and Y-train data set. Next, I'm going to compare. Why I'm joining the both data in the same T-train models mean I'm going to apply in the classification learner. So I want to applying the algorithm, the classification learner. Classification learner application is already available into the app section. App section under the machine learning and deep learning. Here the classification learner apps is there. Based on that, you can directly choose your apps and you can directly train your models. Next, due to some problem, we are not able to view correctly in the application part, and also just showing that steps of the application ended. Okay, choosing for the classification learner. Once you choose the classification learner, here the application part is there. New session is there. New session from the workspace from the file. Choosing based on that, you can train the policies and plot the policies. Finally, export option, export from the figure or function, or generate the function, or export the model, .mat file format. The complete option is available. You can see that picture with the example in the MATLAB software. Okay. Once you open that, once you're done with the pre-processing data sets, and you're going to load your data sets using your classification learner app, where load the data sets. The complete data sets is available in the T-train. Next, in the T-train, we are going to classify the data sets. Once you apply the data sets, you can get the activities. You can see this image, this picture. This picture is a classification learner app. It's kind of 5 kind of activities with the 5 kind of colors: sitting, standing, walking, dancing, running. And then algorithm choosing types here available. Suppose you want to add your own algorithm, that option also available. Here in this example, we are choosing the boosted tree algorithm. We are applying the boosted tree algorithm for the checking accuracy. Suppose this algorithm is not suitable for your models, and also you can easily change your algorithm and check the accuracy result. Based on the accuracy results, we are converting the model to .mat file format. You can see here. Finally, we are converting into the final results. In the accuracy results, we are taking some data sets and we are using the deep machine learning concept classification learner. Why I am choosing the classification learner mean I am classifying the 5 kind of activities: sitting, standing, walking, dancing, running. That's why I am using the classification learner to classify the data sets. After I am getting good accuracy, around my accuracy 97.63, I am applying to save the data sets in the ensemble mat. Finally, on the ensemble map, I'm sending to the data set in the simulation models. Simulation models only is we are making the block set, the Android accelerometer block set, answer Android accelerometer, calibrated XYZ movement, and then predict activities and accelerometer XYZ movement. Final output in the app level and predict activity. We are sending the data sets. Based on the data sets, finally, in the same models, we are deploying to the MATLAB in the mobile phone. Mobile phone in the format of .apk file using USB connection. We are directly deploying the same Simulink model, the complete Simulink model. We are deploying into the mobile phone in the format of APK. Finally, we are getting the apps like that. Based on the activities like X, Y, Z movement, we are predict the activities. What kind of activities? Sitting, standing, walking, and running. Due to some it's taking some time to deploy the model. That's why I'm not practically showing this example. I'm just theoretically explain this concept. I will share the complete files about the deep machine learning concept Based on that, you can try this example with the trial license, MATLAB trial license. Next, we are going back to the presentation slides. Machine learning is the older one. Most often the machine learning concept, we are applying the algorithm. Based on that only we are getting the results. We need to prepare the data, sample data and the output. Based on that, we are getting the accuracy. We are finalizing the results. After that, we are getting the app. Next, we are going for the deep learning. Choosing for the deep learning is completely different from the machine learning. Machine learning concept, we are using some algorithms. Machine learning also, most of nowadays in the most of the papers, research papers and journals, most of them around 30 to 40% in the concept of deep learning only in the published, or very good impact factor published in the papers of deep learning concept. Going for the deep learning is kind of a subset of machine learning concept. Is completely based on the neural networks. Is based on the neural networks is the layer sets. Previous that we are applying some algorithm in the machine learning concept, like a supervised algorithm or unsupervised algorithm, clustering, classification, regression based on the types. We are applying some algorithm, we are getting the output. But deep learning is kind of the neural network. It's completely based on the layer sets. Based on the layer only, we are getting the results. We will briefly see about the deep learning comparison of the deep learning and machine learning. Taking for the machine learning, we are applying some future extraction. Then we are going to the classification. Classification side, we are applying some algorithm. Finally, we are getting the results. But deep learning is completely different. It's a end-to-end learning. It's a both future learning and classification in the inside of the neural network, convolutional neural networks or neural networks. Based on that, we are getting the output. Most of the deep learning concept, we are applying the lot of data, so the image, text, sound. Taking for some applications. Okay, these two are our application. You can see here, image classification, object detection. You want to classify the image classification, just send it the data set. Based on the data sets wise is applying, we are making the layers, and based on that we are getting the results. And of the object detection, you can see here we are applying the object detection based on the size of the particular object into the deep learning concept. We are predict the activities, and also some example. Semantic segmentation. Semantic segmentation is very much useful for the automated car designing and also other concepts. Semantic segmentation is very much tool for the MATLAB deep learning toolbox, and also speech recognition. Speech recognition based on the frequency, you can easily predict the what the word is there. Based on that only the Alexa, Siri, Google Assistant are working. And then suppose you want to some ideas about the semantic segmentation mean Google Lens. Google Lens also similar kind of thing. You can get some idea about the deep learning application. Why deep learning are so popular nowadays? Comparing of the machine learning, deep learning accuracy is much more higher in the machine learning, and the error level is low. Comparing the human accuracy also, error level is low and accuracy is very high. That's why the deep learning is so popular nowadays, and the major success is enabled by the lot of labeled public data sets. We are easily labeled the public data sets, and of course we are going to the deep learning. We need the GPU. Why GPU mean? Most of in the deep learning concept, we are applying the huge data sets, huge image data sets, huge video data sets, huge text data sets. That's why we need the GPU support to run the data set faster. And also in the MATLAB software, lot of pre-trained model is available. Pre-trained models means is nothing but already this model is developed. So example, we are taking for the AlexNet. AlexNet is a 25 layer set. This AlexNet having the millions of images, categories into the 1,000 categories. Say example, we are classify some images mean already that classified image data sets available into the like pre-trained model. Based on that, you can easily classify the models. Choosing for not only for image side, and also lot of deep learning is a versatile. Is not only for images and also text and also frequency level, deep learning, the speech recognition, text data, classify the time series forecasting. image data sets, RCNN, semantic segmentation, sequence to sequence regression methods, and single image super resolution using deep learning concept. Taking for the pre-trained, totally the going for the machine learning. Machine learning is divided into two categories: supervised and unsupervised. And the types of algorithm: classification, clustering, and regression. Clustering is a unsupervised one. Classification and regression is a supervised, under the supervised type. Choosing for the deep learning concept. Deep learning is totally a three type of deep learning is there. One is the pre-trained models. We are not worried about the data sets. We are not worried about the model. Everything is available in the pre-trained model. We are just adding to the MATLAB software based on the pre-trained model what data have. We are classifying the image. That was the one type of the pre-trained model. Next one is a transfer learning model. Why we are using the transfer learning model means most of the pre-trained model not having that much data sets. Based on that transfer learning method, we add your own data sets into the model. Based on that, we are classifying the output. We are upcoming slides. We are see clearly about the transfer learning concept. Next, own trained model. Own trained models nothing but we only develop the complete layers, complete data sets, and complete architecture, including the neural network. Everything we only developing the complete model. That name is own trained deep learning models. We are going to see about one by one the models. First, we are going to the 4-line code about the deep learning concept. The most of in the MATLAB software, you can easily add your pre-trained model. You can see here the MATLAB software. Now I'm switching to the MATLAB software. You can see here this example is around 5-line code about the GoogleNet pre-trained model. Pre-trained model is nothing but already the data is available into the model. We are just add the data set into the MATLAB software. Suppose you want to add some pre-trained model means using own add-ons, get add-ons. Opening the get add-ons, you can just enter your pre-trained model's name. You can see here I'm adding some pre-trained model. Based on the pre-trained model, you can directly classify the data set. Most of the pre-trained models based on the data set wise is different. Based on the layer sets, based on the data sets. I'm choosing the AlexNet now. I want to add AlexNet. You can see here this one, deep learning toolbox model for AlexNet. Once you add this AlexNet pre-trained model, the complete data sets is automatically added into your MATLAB support package. You can now we are going to see about some example relevant GoogleNet AlexNet. First, we are choosing the GoogleNet. And the same example what we are done in the image processing, but this time we are not classifying the image we are not giving any title, we are not applying classification method, we are not any classification method, we are directly based on the pre-trained model, we are classifying the image, what this image. But first I am this coding I'm reading, first I'm reading, I'm showing both things, both function I'm running here. Pepper image, I'm taking the pepper image. Next, I'm loading the pre-trained model. Choosing for the pre-trained model, most of the pre-trained model is available here. You can see the presentation slide. Most of the pre-trained model is there. AlexNet, BGG16, BGG19, GoogleNet, Resnot50, Resnot1. These all are the pre-trained model. You can easily add the pre-trained model using the get add-ons, and also just call the name of net equal to AlexNet, net equal to BG16. These all are the different kind of data sets having, different kind of data sets having. Based on that, you can directly call the data sets into the MATLAB software. Choosing for the these models, I'm choosing the Google pre-trained model. I want to classify this image, what kind of image and what kind of category of this image. Both function I'm using, I am show and then I am read the pepper image. Again, this pepper image I'm calling to the GoogleNet. GoogleNet is nothing but our pre-trained model. Pre-trained model. Once you add the pre-trained model, the complete support package is automatically added to your library. You can see here. Running this model. I'm using the Google Net to classify this image, what kind of category of this image. Next, again, I'm read this image. Why I am resizing means, why I'm here applying to the resize mean, most of the pre-trained model having the standard resolution size. So example, Google Net having the most of this having the standard resolution size class 224 class 224. Then taking for the AlexNet, the standard resolution size is for 227 class 220. Based on that, we are taking the pre-trained model. You can see here, I'm loading the pre-trained model. My pre-trained networks is available here. I'm choosing my pre-trained model. Google Net having a 144 layers. You can see the layers. Around 144 layers is there. The standard resolution size of the layers having 224 class 224. That's why I'm applying here the changes standard resolution 224 class 225. Then only my output also matching with the pre-trained model. Next, I'm classifying this image, both this changed resized image with my pre-trained model. Pre-trained model Google Net. Google Net already having these data sets. Based on the data sets, it's classifying this image is a bell pepper. Category of this image is a bell pepper. This bell pepper, based on the pre-trained model, we are classifying this image. And also we are seeing another one example. This time I'm not using the inbuilt example. I'm using my local path image. Local path image is the tiger image. This tiger image, I'm using the AlexNet. This example is already done, run. That's why it's showing the results. AlexNet having the 25 layer sets. Already this kind of tiger image or other kind of images is already available with the pre-trained model. Millions of images is available in the pre-trained model. Based on that, again I'm resizing. Here you can see my Google Net having the standard resolution size 224 class 224. Here my AlexNet resolution size is 227 class 227. Based on my standard resolution size of the pre-trained model, I'm classifying the image. Here applying the 227 class 225. Finally, I'm classifying this image tiger. Okay, this is a simple example about the deep learning concept pre-trained model. Next, we are going to see about another one pre-trained model into the presentation slide. We added the data sets. This one is a 10-line code, but is completely different than the previous example. Previous example, we are just calling the images only. But this example is yet complete 10 example is classifying my direct web cameras. I'm taking the output also. First, I'm writing the cam equal to web camera. That time, my MATLAB software is automatically calling my loading. Next, the net equal to Google Net is loading my pre-trained model. And based on my live data sets, I'm classifying my image. And then I'm resizing image. Why I'm resizing here means my standard resolution, my pre-trained model standard resolution size is 224 class 224. Based on that, I'm classifying my image, both my live camera images and then taking the images and my neural network image, Google Net pre-trained model image. Based on that, I'm classifying the image. You can see here my final output. I'm directly applying this 10-line code into the MATLAB software, cam equal to webcam, net equal to the Google Net. This cam equal to webcam, my system cameras is automatically access my system cameras. Next, I'm loading the pre-trained model. Pre-trained models already have the data sets. Based on the data sets, I'm lively classifying my images. You can see my outputs. I'm taking the live cameras to the classification. I'm taking this example, going to the classifying my studies the shoot, and then is classifying the other object is this one is the mouse, and then other is this one is the ball pointer. Why showing this kind of results mean this data sets is already available into the pre-trained model. Based on that, we are classifying this example. You can see other examples also. We are giving the water point. Why is not showing the water bottle correct object mean punching bag? This image is also added with my part of the image, my part of the data set. That's why it's showing the punching bag. Most of in the pre-trained model. In the pre-trained model, based on the data sets only is classifying. Based on the what data set? Based on that here this mouse data already is available. This mouse image already is available in the pre-trained model. This Google Net. Based on that is classifying the image. Suppose we are changing the position, angle, or shape, is automatically changing the data. What data sets we are, based on the data sets, is classifying this object. This is a completed 10-line code. We are directly asking the camera and then classifying the images, the final outputs. Next, we are going for the architecture, neural network architecture. Most of in the neural network architecture is based on the input layer and hidden layer and then output layer. We are applying the input layer in the form of images. Hidden layer is nothing but all layers. Hidden layer going for the pre-trained model, already the layer sets is available here. Going for the pre-trained model, already the data sets developed. But our own trained model, we only develop the complete neural networks. That explained here, the hidden layers. Finally, we are getting the output layers. The working principle of the convolutional neural network. First, we are taking one image. This image is sending to the other layer and future learning, other sending to the other layer classification. Right? Totally in the future learning and classification, 6 major layers is there. Convolutional, RULA and pooling layer. Classification side, flat and fully connected softmax. These are the 6 major layer sets. Choosing the approaches of the deep learning. We already know that there's 3 kind of types in the deep learning. Approaches first, in the pre-trained model. Pre-trained models already having the data sets. Based on the data sets, we are classifying the image. But train the deep network from the scratch. From the scratch means own trained model. We only applying the full data sets. We only create the full layer set. Finally, we only get the results. But another one method is the transfer learning. Transfer learning is the fine-tune a pre-trained model. We know we don't worry about the complete data sets. We are classifying some pre-trained model, but the data set is not suitable. The data set is not predictive particular images or particular data. Based on that, you can add some data. The transfer learning, you can directly fine-tune your pre-trained model. Suppose you want to add some data. You already the pre-trained model is there, but in the pre-trained model is not predict, but correct output means you can directly choosing in the transfer learning, you can add some more data into the transfer learning. Based on that, you can directly make you fine-tune your pre-trained model and getting the result. The disadvantage of transfer learning, you're not able to apply the above 1000 labeled of images. This is completely small data. Suppose you some data is not available into the pre-trained model. That time only you can add your data sets, and then that advantage of own trained model, you can apply 1000 to millions of images. This one is no need for the GPU support. This one is needing the GPU support. The training times is second to minutes. The pre-transfer learning method, own trained model, we taking the day to weeks because we are applying the millions of images. The accuracy level is very high. Based on that data sets only, we are applying the results, right? That's why it's showing getting the accuracy results. But model accuracy in the transfer learning, already the layer sets are added. Based on that, we are just adding your data set. That's only we are getting the good results. Going for the transfer learning method, first the second method, transfer learning method. Transfer learning method is nothing but we are fine-tuning the pre-trained model. We are adding some data into the pre-trained model, load the pre-trained models and replace the final. We are not changing the full layer, just we are replacing the final layer. Finally, we are getting the training network accuracy, train the networks. Then finally, we are getting the predicted network accuracy, and then we are deploying to the results. We are going to some example. The same example is the transfer learning method. Using the fine-tuned pre-trained model, that this one is the transfer learning method. We are applying the 5 data sets: big cars, big trucks, cars, SUV, trucks, and van. 5 class of classification. First, we are going to see about the why we are applying the transfer learning base. This one I am using the pre-trained model. Pre-trained name called AlexNet. You can see my output for this road picture classification. I want this. This output mean I want the output of this video. I want to classify the object, how many vehicles in the road, what kind of types of the vehicle in the road. I want to classify using the pre-trained model. I'm directly applying the pre-trained model name called AlexNet. You can see this AlexNet pre-trained model don't having these data sets, this car data sets. Only the having other data sets, other kind of data sets. That's why I'm applying the transfer learning to making the add my data sets. It is not detecting the particular images into the object. transfer learning method. After the data set, after applying these 5 kind of data sets, I'm getting the results. You can see I'm not making the complete layer sets. I'm just adding my data sets in the pre-trained model. You can see my output of this after the transfer learning method applied data sets. You can see trucks SUV is 0.81%, and cars, and then SUV. I'm using the pre-trained model. Based on the pre-trained model, I'm adding my data sets. I'm adding this 5 kind of data sets in the pre-trained model. I'm fine-tuning the pre-trained model. We are going to see about this example into the MATLAB software. Going for the fine-tune method, I already having the data sets. You can see my data sets in my local in my PC. 5 kind of activities of data sets. Big trucks. I'm not directly detecting. I'm based on the data sets only. I'm detecting the data images, finding the vehicles, applying to the big trucks images, and then car images, and then SUV images, and then trucks, and then finally vans. Based on the data sets, I'm directly loading my pre-trained model. I'm fine-tune my pre-trained model into the MATLAB software. Using MATLAB software, you can see my transfer learning method. This example, I'm just replacing my final layers. I'm not creating the full complete layer. I'm just replacing my final layer. You can see the coding. In this coding, I'm not doing anything. I'm just replacing the layer sets. I'm loading the data sets, complete data sets, the 5 kind of activity data sets, 5 kind of vehicle care data sets, and then I'm replacing the layer. I'm loading my pre-trained model name called AlexNet. AlexNet don't have the data sets. That's why I'm using the pre-trained, replacing the layer sets. I'm fine-tune the layer sets. I'm adding 2 more layers, a flat and fully connected layer. Fully connected layer, classification layer. Based on the classification layer, I'm classifying the image data set. Finally, I'm getting the result to classifying the based on my data sets is classifying my pre-trained model. The final output of the pre-trained model. We are just adding the data set in the pre-trained model. That name called fine-tuned pre-trained model. And another name called transfer learning. That second method of the second type of the deep learning. We are just add the data set into the pre-trained model. Why we are adding the data set mean the pre-trained model is not correctly detecting the data set. That's why we are adding our own data sets to making the modification of the transfer learning method. Choosing for the layer sets inside of the layer sets. The layer sets is nothing but this layer concept. Inside of the hidden layers, future learning and classification, this layer concept, neural networks, convolutional RULU, pooling and flattened fully connected software. Choosing for the layers, these are the major layers working principle. Taking for this first layer in the future learning, the 3 layers is important: convolutional, max pooling, and RULU layer. First layer, convolutional layer, is nothing but detecting is like a pattern wise. Suppose you are sending your data set into the layer, first layer, convolutional layer. Convolutional layer, we are searching the data set based on the pattern wise, based on the circle pattern, line pattern, based on the pattern wise is detecting the data sets. Next, we are going to the max pooling layer. We are next is classifying the images, is sending to the another layer. That layer is based on the maximum pooling layer. Maximum pooling layer is nothing but maximum value of the data set. Okay, here you can see 1034. The maximum value is taking to the sending to the another layer. Next, another layer, rectifier linear unit layer. Rectifier linear unit layer, negative values is converted to the 0. Matching like a negative values is converted to the 0. Based on that, is classifying the layers. Next, classification side, 3 layers are important: fully connected layer, softmax layer, and classification layer. Classification layer is based on the categories of the image. Softmax layer is based on the probabilities based. Fully connected layers is based on the specific categories of the images. Choosing for the layer sets, suppose you want to develop in your own trained models into the MATLAB software. MATLAB software having the MATLAB software application name called Deep Network Designer. In the toolbox or under the toolbox of deep learning toolboxes, you can easily design your layer sets. You can see here. Just load your data sets and choosing your layers, what kind of layers you want: input layer, output layer, hidden layer, RU layer, convolutional layer. Every layer you can directly pick and place here, and auto arrange option is there. Auto arrange option is there. Analyze option is there. Export option is there. Based on the export, you can directly convert the coding option also. You can easily convert to the coding. Based on that, you can directly making your deep learning own trained model. Next, going for the frameworks of the MATLAB deep learning framework. First, we need to the data sets. Design and train. Design and train, we are using the easy to access to the model. Scale to GPU and cluster. Finally, deploying method. You can directly optimize the Intel development, and the NVIDIA Intel ARM platform you can directly deploy into the hardware. You can see some deploying of the platform of choose based on your choosing option. You can directly deploy into the hardware. NVIDIA Jetson TXL board, Android phones, Intel desktops, Raspberry board, everything you can directly deploy. No need to worry about the deploying option. Based on the also you can convert to the NVIDIA to GPU code or GPU code also you can easily convert. Based on the hardware, based on the choosing your hardware, you can directly deploy your complete models. The final one-step deployment: access data, pre-process, select network, train and deploy. First, we need to the access data where we are accessing data. This is used for own trained model. Own trained model is nothing but we only making the complete layer sets. You can see the own trained model example. Own trained model example. I'm taking some brain tumor detection example. Okay, I'm choosing the MATLAB. So here you can see in the previous two types, one type is the transfer learning, one type is the pre-trained model. Pre-trained models, we are directly using the pre-trained, load the pre-trained models. We are classifying the image. You can see one by one examples. The comparison of 3 types. The first one, pre-trained model. Pre-trained model, we are load the pre-trained model. Based on the pre-trained model, we are classifying the image. Second one, transfer learning method. Transfer learning method, we nothing but we add own data set, fine tune your pre-trained model. Based on that, we are classifying the image. Third one is a own trained model. Own trained model is nothing but we only making the complete layer sets. Here you can see we only making the complete layer sets. We only making the complete layer sets. Here you can see the previous that we are not making the layer sets based on the convolutional, RU, pooling, max pooling, softmax, future learning and classification side. But in the own trained model, we are loading the data based on the layer function. We are making the layer sets. In the same thing, you can using the deep network design in the apps. Under the deep network designer, you can directly making the layers. No need to worry about the programming. No need to worry about the coding and all. Using the deep network designer, you can directly choose your particular particular layer sets. What kind of layer sets you want, you can directly choose using the applications. You can see the application part. Deep network designer app. You can completely make your layer sets using the deep network designer. you can directly load your pre-trained model also in the deep network. Suppose you are doing some transfer learning method, or you want to create your own trained model using deep network designer, you can directly choose your layer sets. Here you can see import from the workspace or your pre-trained models or the black model. Suppose you want to make your new neural network completely ASH, means choosing the new option, you won't train and place your layer sets. I need some input layer convolutional based on the layer function. You can directly choose your layer sets. Assigning option is there. You can directly assign the options. No need to worry about the codings also. You can auto range option is there. Analyze up there. Suppose you want to convert the coding, generate. Once you applying to the generate code, this particular application final output is automatically coming to a MATLAB coding. You can see the MATLAB screen. The same layer sets is automatically converted. No need to worry about the coding also. This is very much useful for the deep learning beginners. Easily you can make your own trained model, transfer learning models or pre-trained models. Suppose you want to add much more data in the pre-trained model, that option also you can directly using the apps under the deep network designers. And also finally you can easily convert the coding. No need to worry about the coding also. Finally, this code you can easily deploy into the some hardwares. What kind of data sets you prepared, you can directly deploy into the hardwares also. Coming back to the presentation, the final one step deployment stage. Access data, image acquisition toolbox, pre-process image processing, computer vision, neural network, train models, we are using parallel computing, deploy using the GPU coder, we are directly deploying. The final topic, MATLAB user story on artificial intelligence. This user kernel bioacoustic scientist development high performance computing platform for analyze big data. The major challenges of this user is not able to detect and classify the animals. Most of in the we have the human count. We know the particular areas. We know the particular circle. We are going going to some person and detecting how many people's into the surrounding. Easily identifying the human count. But animals and plants, we're not able to count how many animals in the particular circle. Using this using MATLAB software, deep learning, fuzzy logic, image processing, signal processing, MATLAB parallel computer, statics and machine learning toolbox, artificial intelligence product, easily count, detecting the animals in the different kind of ocean, field, forest, jungles, in the sound and picture basis. Based on the sound, based on the picture, easily detecting how many animals in the surrounding, easily count the how many animals in the how many plants in the surrounding using this MATLAB toolboxes. The final result of the end user is years to development time is saved, and analyzing time. Basically the analyzing time is based on the data meshing only is done, but using deep learning and machine learning concept, big 2 hours. This reducing the times to big 2 hours, and previously processed data is analyzed in the days, and also predict the much more data sets. Using this toolbox, you can easily detect in the used data sets. This is one user story. And then already we discussed yesterday about the trial license, 30 days trial license option of the door, and 2 hours MATLAB free on-ramp courses is available. Especially for artificial intelligence, we are giving machine learning and deep learning on-ramp courses. This is very much useful for the beginners in the artificial intelligence side. With this, I conclude my presentation. Thank you all for the listening. Kindly write your question into the chat box.
Thank you, sir.
Thank you, sir. Basically, we don't have that much time to explain about the concept. We have artificial intelligence is a huge one. We're not able to give much to explain about within 1 hour. But I hope
Yes.
you can get some ideas about the artificial intelligence concept. Now, time for the question answer. Kindly write in the chat box.
Participants, you can post your questions in the chat box.
Suppose in the future you have any questions, this is my mail ID.
Sir,
and
one
contact
person in
number.
the chat box asked that what is the difference between machine learning algorithm and model?
Machine learning algorithm is based on the algorithm. Machine learning concept is basically completely based on the algorithm, choosing for the supervised and unsupervised. Models means we are developing some simulation. We are applying some block level development. That is a model based design. We are using the Simile product family to developing the models.
Okay. Thank you, sir. What are the toolbox needed for a signal processing using deep learning?
Signal processing, choosing for the signal processing, only three major toolboxes needed. One is a signal processing toolbox, another one is a MATLAB, fundamental MATLAB, another one is a deep learning toolbox. Three toolboxes is enough for that.
Sir, one participant asked that in MATLAB trial version, do we have all the toolboxes?
Based on the categories of products, already we have discussed yesterday, based on the selection of the product. Suppose you want to do the bulk of products in the machine learning, artificial intelligence side, or you want to some image processing, or you want to some signal processing, or wireless communication, autonomous system. The complete listed is automatically showing to the choosing trial license bulk option. Based on that, you can get the toolboxes. Sir.
Okay, sir. Sir, trial version, how many days it will be working?
30 days, sir.
30 days.
Yes, sir.
Okay, sir. Thank you. Sir,
Some people, yes, sir.
Another participant asked that suggest a best speech recognition algorithm in natural language processing.
Natural best speech, right?
Yes, sir.
Natural language processing. In this type, I don't. I also don't know correct pretended model or correct things. I will check and give the correct details about the speech recognition. And also the speech recognition side, ResNet, I think getting the very good classification side.
Okay, sir.
I will share the details and check the details, and I will share the detail to you. You will share the particular person, sir.
Okay, sir. Okay, sir. Thank you. Sir, when using the MATLAB, is it accuracy? Accuracy is very good or somewhat better using the MATLAB?
Accuracy comparing to the using the MATLAB, correct. Actually, in the MATLAB software, you can get the very good accuracy. Most of in the deep learning concept, you are choosing the deep learning concept based on the data sets. Say example, in the same images, I want to classify one images into the particular object. I have a 10 data sets. Say taking for the mouse image, I have a 10 mouse image data sets. But I'm changing the 10 images having a standard same size. It's not angle. It's not having different kind of shapes, angle, and position. It's all are the same shape only. But I want to predict the data set in my in the pre-trained model means, and then my model means I cannot having the different kind of shapes, angle data sets. Based on the data sets only, we can get the accuracy. How many data sets you are applying? Based on the data set only, you can get the data set. You can apply the more data set, you can get the more very good accuracies.
Okay,
Data set means you can get that much accuracy.
Sir, for linking with the LabVIEW software, is it possible to use the MATLAB?
Linking, going for the model-based design types, you can changing the model, but you cannot link it to the LabVIEW. But you can directly deploy to the hardware. Suppose you want to deploy some embedded devices, or you want to deploy some FPGAs, or you want to deploy some vertex boards. That option is available, but model conversions is not available. Only coding side we are the Python. You can directly import from the Python coding or export from the Python coding. That option is available. In LabVIEW, we are not supporting anything. Sir.
Okay, sir. Another one participant asked that MATLAB support IoT data sets.
Yeah, MATLAB supported IoT datasets, and also MATLAB support the third-party support package named ThinkSpeak. Based on the ThinkSpeak support package, you can easily making your IoT projects. Using the add-ons, you can easily add in the ThinkSpeak support package also. Sir.
Okay, sir. Okay, sir. So I think most of the question we have answered. HOD sir.
Hello, sir.
Sir, can we complete the session, sir?
Okay, sir. Okay, you come in. You proceed.
Oh, vote of thanks. We can go for vote of thanks, sir.
In the future, if you have any doubt, I already share my contact details and mail ID in the chat box. If you have any queries, please feel to mail me.
Sure, sir. Thank you.
Thank you, sir.
All the participants can kindly use the contact details of our eminent speaker, D. Rajkumar, Design Tech Chennai. Posted his mail ID and the phone number in the chat box. You can make use of it. Okay, finally, vote of thanks. So first of all, I thank my management of EGS Pillay Engineering College Autonomous, accredited by NAC and NBA for all the department. Thank you all the participants for wonderful support you have extended for the 2-day session with patience and full of interest in listening and learning without any hesitation. Thank you all. Also, I thank my HOD sir, Dr. S.M. Ramesh, for supporting me for arranging this program in a grand, successful manner. And I am very much thankful for those who is behind all this 2 days online webinar in a successful manner. None other than our Honorable CEO, Dr. Chandrasekhar sir, and our Professor PRO, Jim Hawkinson sir. Thank you, sir. Finally, I thank our eminent speaker, Mr. D. Rajkumar, Application Engineer, Design Tech, Chennai, for wonderful informative speech and real-time explanation using MATLAB, which is very useful and helpful in every way for our career and also in the research work. Thank you once again, sir.
Thank you,
Hope
sir.
it will extend in future also. Thank you,
Sure,
one and
sir.
all. Thank you, one and all. Kindly fill the feedback form to get the certificate for this 2-day online webinar workshop. At the end of the session, make use of it. Thank you.
Thank you all.
Participants, please kindly note that you will be redirected to the certificate link immediately after this program, and YouTube will be link will be available tomorrow, and we will be sending it through your mail. So thanks for the participation. Now you will be redirected to the link.
Also, the PPT will be sent to your mail ID, which is filled in your feedback form. So kindly clearly mention your mail ID and your name. We will be send your PPT materials and all the supporting documents to your mail. Thank you.
Thank you all.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir. Jim, sir, you can redirect or send the
Yeah,
link.
it is sent, sir. It is sent.
Okay, sir.